Tonight, we explore why the most comforting explanations for our cosmic isolation have collapsed, leaving us to face a reality where the silence of the universe is no longer a mystery, but a warning. For decades, we told ourselves a soothing lie. We said the cosmos was simply too vast, our telescopes too weak, and our search too brief to expect a response. We believed that finding another Earth was like hunting for a microscopic needle in an endless, dark haystack. But that era of comfortable ignorance is over. The data has poured in. Our machines have stared into the deep void, mapping billions of worlds and cataloguing the very chemistry of creation drifting between the stars. The universe we now know mathematically is perfectly engineered to spark life. It has had more than enough time and more than enough material to fill the galaxy with sprawling empires. We should be deafened by their radio chatter. Instead, there is nothing. And the real reason why nobody is talking will fundamentally change how you view the future of our species. It was the summer of 1950 in the high desert of Los Alamos, New Mexico. The sun was beating down as four physicists walked toward the cafeteria. These were men who had recently unlocked the terrifying power of the atom, men whose daily lives revolved around splitting the fundamental building blocks of reality. The conversation was light, drifting from a recent cartoon in The New Yorker about aliens stealing municipal trash cans to the sudden spike in flying saucer reports filling the daily newspapers. They laughed, they sat down to eat. And then, without any dramatic pause or build-up, the physicist Enrico Fermi set down his fork and asked a question that would completely rupture our understanding of our place in the cosmos. He simply asked, "Where is everybody?" His colleagues laughed at first, assuming it was a casual punchline. But Fermi was not joking. During the walk to lunch, his mind had been silently churning through the numbers. Fermi was a human calculator, a physicist renowned for his ability to intuitively estimate the yield of a nuclear detonation just by dropping scraps of paper into the blast wave. Now, he was applying that same brutal, unyielding logic to the stars. He calculated the age of the galaxy, the sheer number of suns, and the time it would take a single, technologically capable species to spread outward. Even at incredibly modest speeds, an expansionist civilization could sweep across the entire Milky Way in a few million years, a mere blink of an eye in cosmic time. The math dictated that the galaxy should be teeming. It should be overflowing with the radio chatter of alien empires, the infrared glow of their massive stellar engineering projects, and fleets of automated probes drifting through our own solar system. The math insisted we should be surrounded. Instead, Fermi realized, we see absolutely nothing. In 1950, this was merely a dark thought experiment over pasta. Fermi was asking the question with virtually no astronomical data to back it up. There were no confirmed planets outside our solar system. We had no evidence of water on Mars or organic molecules drifting through the void. It was a puzzle wrapped in pure ignorance. Today, the ignorance is gone. We have the data. We have built telescopes the size of football fields and launched observatories that stare into the deep black with unimaginable precision. We have looked harder, longer, and deeper than any generation in the history of our species. And the answer we are getting back keeps getting worse. For decades, we wrapped ourselves in a comforting blanket of astronomical excuses. We told ourselves that Earth was a freak accident, a rare, miraculous oasis in a hostile desert. We assumed that planets were incredibly rare, and that solar systems with stable, rocky worlds in the habitable zone were essentially statistical anomalies. Then NASA launched the Kepler Space Telescope. Kepler stared continuously at a single small patch of sky for 4 years, watching over 150,000 stars for the microscopic dip in light caused by a planet crossing in front of its sun. The precision required was akin to spotting a moth fluttering past a stadium floodlight from 1,000 miles away. The results from Kepler didn't just update the textbooks, they violently shattered our preconceived notions of a lonely universe. Planets are not rare, they are everywhere. The data revealed that roughly 1 in 5 sun-like stars hosts a rocky planet situated perfectly in the habitable zone, the orbital region where liquid water can exist on the surface. When you apply that ratio to the Milky Way, you get roughly 11 billion potentially habitable, Earth-sized worlds in our galaxy alone. Expand that count to include planets orbiting red dwarf stars, which are vastly more numerous, and that number skyrockets into the tens of billions. Tens of billions of worlds orbiting in the warm zones of their stars in a galaxy that has been producing them for over 13 billion years. And it isn't just the planetary real estate that is common. The chemical building blocks of biology, the very sparks of life, are aggressively ubiquitous. We have detected complex organic molecules drifting in cold interstellar gas clouds. We have found the precursors to amino acids in the tails of comets and inside meteorites that have crashed into Earth's surface. Water, the universal solvent for life as we know it, is one of the most common molecules in the universe. The ingredients for biology are not confined to our pale blue dot. They are scattered across the void like seeds blown across an endless field. This is the foundation of the modern nightmare. The galaxy is incredibly old. Habitable planets are abundant. The chemistry of life is commonplace. The time available for evolution is practically infinite. Every single factor we can measure screams that the cosmos should be a crowded, deafening biological jungle, yet the silence remains absolute. And it is not for lack of trying to hear them. The search for extraterrestrial intelligence has grown from a single man pointing a radio dish in 1960 to multi-million-dollar initiatives surveying millions of star systems. We have scanned the galactic plane and dozens of neighboring galaxies across an enormous spectrum of frequencies. We have searched for the waste heat of Dyson spheres across 100,000 entirely different galaxies, looking for the infrared glow of advanced technology. The result is always zero. Scientists used to argue that we had only searched a tiny fraction of the cosmic haystack, perhaps a bathtub's worth of water compared to Earth's oceans. But recent analyses have proven that this is no longer true. The volume of the haystack we have rummaged through is now vast enough to set hard, unyielding limits. Within a sphere stretching roughly 160 light-years in every direction from where you sit, no one is continuously broadcasting with the strength of even our own modest power grid. That sphere contains thousands of stars, many with habitable planets. Statistically, several should host life, and at least a few should have discovered radio. But the local neighborhood is dead air. This is the terrifying paradox of new data. Every time we launch a better telescope, every time we confirm another exoplanet, every time we discover organic chemistry floating in the dark, the Fermi Paradox does not get closer to being solved. It actively gets worse. Every discovery removes another comforting excuse. We are rapidly running out of reasons to explain why the sky is empty. The silence of the universe has morphed from a curious scientific puzzle into a deeply suspicious anomaly. We are forced to confront the chilling reality that starting life might be incredibly easy, but surviving it is almost impossible. The void is not empty because the universe failed to spark intelligence. It is empty because something somewhere in the dark is actively filtering intelligence out of existence. And as we stare into the deafening quiet, we have to ask ourselves, has that filter already wiped them all out, or is it waiting for us right around the corner? For decades, we possessed a psychological defense mechanism against the deafening silence of the cosmos. A soothing bedtime story we told ourselves to make the vast, empty dark feel a little less menacing. We convinced ourselves that Earth was a miraculous, impossible freak accident. We looked at the sheer complexity of our biosphere and decided that the sequence of events required to produce us was so staggeringly improbable that it essentially rounded down to zero anywhere else. This idea, popularized as the rare Earth hypothesis, became the easiest excuse for the Fermi Paradox, allowing us to stare into a seemingly dead galaxy and feel special rather than terrified. The comfort lay in the incredible specificity of our existence. We argued that for a planet to support complex life, it needed to sit in a highly restricted sliver of galactic real estate, far enough from the chaotic, radiation-soaked center, but close enough to the heavy elements forged by ancient supernovae. We told ourselves that you needed a quiet, stable star that wouldn't strip your atmosphere away with violent solar flares. You needed a colossal gas giant perfectly positioned in the outer solar system, like Jupiter, acting as a gravitational vacuum cleaner, sweeping up the apocalyptic comets and asteroids that would otherwise repeatedly sterilize the inner planets. But the list of necessary miracles didn't stop in space, it extended deep into the planet's crust. We assured ourselves that you needed active plate tectonics to act as a planetary thermostat, recycling carbon and preventing the world from freezing over or boiling into a runaway greenhouse effect like Venus. You needed a molten iron core generating a powerful magnetic field to deflect the lethal solar wind. You even needed a disproportionately massive moon formed by a once-in-a-billion-years planetary collision just to stabilize your world's axial tilt and prevent wild, chaotic climate swings over geological timescales. By stacking these impossibilities on top of each other, we built a fortress of improbability. The math of the rare Earth hypothesis suggested that we were a cosmic lottery winner, holding the only winning ticket in a universe of dead rocks. The silence wasn't a threat. It was just the natural sound of an empty room where we were the only guests. But this comfort was a fragile illusion, and modern astrophysics has violently dismantled it. The destruction of our favorite excuse began in earnest when NASA launched the Kepler Space Telescope, an instrument designed to stare unblinking at a single patch of sky to catch the microscopic shadows cast by planets crossing the faces of their distant suns. Before Kepler, the idea of planets existing outside our solar system was an unproven theory, a hopeful guess. After Kepler, the data washed over us like a tidal wave, completely shattering our preconceived notions of a lonely, sterile universe. The telescope proved that planets are not rare anomalies. They are the standard operating procedure of the cosmos. The data revealed that roughly 1 in 5 Sun-like stars hosts a rocky, Earth-sized planet perfectly situated in the habitable zone, the narrow orbital band where temperatures allow liquid water to pool on the surface. When you apply that ratio to the Milky Way, you are forced to confront a staggering reality. There are approximately 11 billion potentially habitable, Earth-sized worlds in our galaxy alone. When you expand that count to include planets orbiting red dwarf stars, the number climbs into the tens of billions. Tens of billions of habitable worlds in a galaxy that has been steadily churning them out for over 13 billion years. And it is not just the planetary real estate that is aggressively common. The fundamental ingredients for biology are scattered across the void like dust. We once thought the chemistry of life was a localized miracle, but we now know the universe is literally wired to create the components of biology. Astronomers have detected massive clouds of complex organic molecules drifting in the freezing vacuum of interstellar space. We have found amino acids, the fundamental building blocks of proteins, embedded inside meteorites that have crashed into Earth's surface. We have discovered that the universe is soaked in water, one of the most common molecules in existence, sloshing beneath the icy crusts of moons like Europa and Enceladus, and locked in the tails of countless comets. The chemical precursors necessary for life are not rare, precious commodities. They are pre-baked into the fabric of the cosmos, delivered freely with almost every solar system. This revelation is the pivot point where astronomical wonder curdles into existential dread. If habitable planets are everywhere and the chemical sparks of life are ubiquitous, then the transition from dead matter to living organisms should have happened billions of times. The universe should be a sprawling, biological jungle. And yet the silence remains absolute. This brings us face to face with the terrifying logic of the Great Filter, a concept proposed by economist Robin Hanson, which states that somewhere between the formation of a lifeless rock and the rise of a galaxy-spanning empire, there is a bottleneck that almost nothing survives. For years, the rare Earth hypothesis allowed us to believe the filter was behind us. We thought the impossibly hard step was simply getting the right planet and sparking the first living cell. We thought we had already survived the hardest trial the universe had to offer. But if the universe is perfectly engineered to spark life, if the chemistry is easy and the planets are everywhere, then the filter cannot be behind us. It must be waiting for us. This is why the philosopher Nick Bostrom has famously argued that finding even a single fossilized microbe in the dirt of Mars would be the worst news in the history of humanity. If we discover that life sparked into existence independently on two adjacent rocks orbiting the same unexceptional star, it proves that the genesis of life is incredibly cheap and common. It would prove that the universe is constantly generating biology. And if the universe is highly efficient at creating life, but utterly silent, it implies a terrifying truth. Starting life is easy, but surviving it is almost impossible. The death of the rare earth comfort leaves us entirely exposed. We can no longer hide behind the idea that we are a miraculous exception. We are an ordinary species, sitting on an ordinary rock, surrounded by tens of billions of identical rocks, hurtling toward a threshold that billions of others must have reached before us. The silence of the night sky is no longer an empty crib waiting for its first child. It is a sprawling, infinite graveyard. And the most horrifying question we must now ask is not why the universe is empty, but what reliable, ruthlessly efficient force is waiting in the dark to exterminate everything that gets exactly as far as we have. There was a time, not so long ago in the span of human history, when we looked up at the endless canopy of stars with an almost childlike innocence. We possessed a profound, unshakable optimism about our place in the cosmos, driven by the belief that intelligence was a universal virtue, and that any mind capable of building a radio telescope would naturally be curious, benevolent, and eager to make a friend in the dark. During the mid-20th century, as humanity first slipped the surly bonds of Earth gravity and walked upon the dust of our moon, we felt an immense romantic urge to introduce ourselves to the neighborhood. We assumed the universe was a grand cooperative frontier, waiting with open arms for humanity to finally arrive and take its seat at the galactic table. This era of cosmic naivety peaked in the 1970s, a decade characterized by a desperate, almost reckless desire to shout our existence into the void. We did not simply listen for whispers from the dark. We actively stood on the porch of our solar system and screamed our coordinates into the night. On November 16, 1974, researchers utilized the massive Arecibo radio telescope in Puerto Rico to beam a highly concentrated, powerful radio transmission toward Messier 13, a densely packed globular star cluster located 25,000 light-years away. We crafted a message consisting of 1,679 binary digits, carefully arranged in a grid. When decoded, this grid revealed a pixelated, proudly vulnerable portrait of our species. We transmitted the double helix structure of our DNA, the atomic numbers of the elements that make up our bodies, a diagram of our solar system, and a stick figure representation of a human being. We packaged our biological blueprint and our exact astronomical address, aimed it at a cluster of hundreds of thousands of ancient stars, and fired it at the speed of light. But our desire to be known did not stop at radio waves. We wanted to leave physical monuments of our existence, messages in bottles tossed into the cosmic ocean. When the Pioneer 10 and 11 spacecraft launched in 1972 and 1973, destined to be the first human-made objects to leave the solar system, they carried gold-plated aluminum plaques bolted to their frames. Etched into the gold were the nude figures of a human man and woman standing next to a diagram of the spacecraft for scale. In 1977, we pushed this romanticism even further with the launch of Voyager 1 and 2, equipping each with a 12-inch, gold-plated copper phonograph record. Championed by the astronomer Carl Sagan, these golden records contained the sounds of Earth, the rustling of wind, the rumble of thunder, the songs of humpback whales, a kiss, a mother's first words to her newborn child, and greetings in 55 different human languages. Sagan and his team viewed the golden record as a beautiful, poetic gesture of goodwill, a testament to the diversity and spirit of our pale blue dot. But engraved on the covers of both the Voyager records and the Pioneer plaques was something far more consequential than a recording of a baby crying. We inscribed a map using 14 rapidly spinning neutron stars, known as pulsars, cosmic lighthouses whose precise radiation pulses can be used as permanent, unaltering galactic landmarks. We drew a highly specific triangulation map directly to our sun. We handed any entity that might intercept these probes a flawless, eternal set of directions to our home. At the time, this was celebrated as a triumph of human vision. We assumed, with the supreme confidence of a species that had never encountered a predator from the stars, that whoever found these messages would be peaceful. We told ourselves the comforting story that any civilization advanced enough to traverse the unimaginable gulfs between stars would have necessarily outgrown war, aggression, and conquest. We believed that technological mastery required spiritual and ethical enlightenment. Today, that optimism is dead. As decades passed and our understanding of the universe deepened, the astronomical community experienced a profound, chilling psychological pivot. The more we learned about the sheer age of the cosmos, the violent physics of the galaxy, and the ruthless, unyielding nature of biological competition, the more our 1970s outreach began to look less like a poetic greeting and more like a catastrophic mistake. The transition to fear was quiet at first, discussed in academic papers and hypothetical game theory scenarios, but it eventually breached the public consciousness. In 2010, the brilliant theoretical physicist Stephen Hawking publicly warned that humanity should immediately stop attempting to contact extraterrestrial life. He explicitly compared the potential arrival of an advanced alien civilization on Earth to Christopher Columbus landing in the Americas, an encounter that ended in the absolute devastation of the less technologically advanced native populations. Hawking and others recognized a brutal historical precedent of the roughly 50 documented cases of first contact between technologically unequal human civilizations over the past 5 centuries. Almost zero resulted in the less advanced civilization surviving in its original form. Extrapolate that dynamic from a gap of a few hundred years of technology to a gap of 1,000,000 years, and the concept of an alien encounter transforms from a scientific marvel into an extinction event. The United Kingdom's Astronomer Royal, Martin Rees, reflecting on the pulsar map we attached to the Voyager probes, would later call it the most reckless act in human history. To understand why some of the most brilliant minds on our planet became genuinely terrified of our own radio broadcasts, you must strip away the Hollywood tropes of evil, drooling alien monsters. The modern dread of the Fermi Paradox does not rely on aliens being inherently malicious, cruel, or aggressive. It relies entirely on cold, mathematical game theory, a concept popularized as the dark forest theory. Imagine the universe not as a utopian galactic federation, but as an endless, pitch-black forest at night. You are a hunter walking through the trees, armed but completely blind to what lies beyond the reach of your own hands. You know, mathematically, that the forest is vast, and you know there must be other hunters moving silently through the dark. The game theory of the dark forest is built on 2 inescapable axioms. First, the primary goal of every living civilization is survival. Second, civilizations constantly grow and expand, but the matter and energy in the universe are fundamentally finite. Therefore, in the very long run, civilizations expanding through the same region of space are in structural competition for the exact same resources. Now, introduce the insurmountable barrier of deep space. If you are a hunter in this forest and you suddenly hear a twig snap, if you detect a radio signal from a star 1,000 light-years away, you face a paralyzing dilemma. You cannot possibly know the true intentions of the intelligence that sent that signal. You cannot call out to them and ask if they are friendly, because the speed of light dictates that your question will take a millennium to reach them, and their answer will take another millennium to return. 2,000 years of waiting in the dark. By the time their reply arrives, their society may have evolved in ways you cannot comprehend, developing weapons you cannot imagine. Because communication is effectively impossible on a relevant timescale, you can never establish trust. A civilization you detect might be peaceful today, but what will they be in 1,000,000 years? What if they fear you? What if they are currently debating whether you are a threat to them? The cost of assuming they are benign and being wrong is the complete annihilation of your entire species. The cost of assuming they are hostile and destroying them first is merely the expenditure of a weapon. In a universe governed by finite resources and absolute uncertainty, the asymmetry of risk strongly favors preemptive action. Therefore, the only logical, rational strategy for any advanced civilization upon discovering another is not to say hello, but to immediately launch a preemptive relativistic strike to eliminate a potential future competitor before they can become a threat. It is not an act of malice, it is the tragic, inescapable mathematics of survival. Under this framework, the terrifying absolute silence of the night sky finally makes perfect sense. The universe is not an empty void. The silence we observe is not the absence of civilizations, it is the sound of a universe holding its breath in sheer terror. The galaxy is a dark forest, and every single advanced civilization is an armed hunter stalking through the trees, holding their breath, masking their thermal signatures, and listening desperately for the slightest sound. Any civilization foolish enough to make a noise, to build a highly visible megastructure, to broadcast a high-powered radio greeting, to light a fire in the middle of the dark forest, is instantly targeted and wiped out by something lurking in the shadows. The silence of the cosmos is an enforced silence. It is the heavy, suffocating quiet of a battlefield where the snipers are already in position and the first one to raise their head loses it. This realization reframes the Fermi Paradox entirely. The universe is quiet because the older species learned the hard way that being loud is a death sentence. The civilizations that survive are the ones that figure out the rules of the game early. They understand that broadcasting your existence to an unknown audience carries unknown, potentially existential risks. And the only rational response is to turn off the transmitters and hide. Natural selection on a cosmic scale ruthlessly favors silence. Those who broadcast are eradicated, those who hide endure. We are looking at a sky filled with hidden empires, a galaxy paralyzed by recursive, compounding fear, where millions of species are trapped in their own solar systems, terrified of making a sound, desperately hoping someone else speaks first. And this brings us to the agonizing, chilling horror of our own situation. We did not know the rules of the forest. For over a century, humanity has been indiscriminately bleeding electromagnetic radiation into the void. Our early radar systems, our television broadcasts, and our military communications have formed an expanding sphere of noise, radiating outward at the speed of light. While it is true that our ambient, unintentional television leakage becomes smeared and weakened by the cosmic background noise after a few dozen light years, our deliberate, high-powered messages are entirely different. The Arecibo message was a highly focused, concentrated beam of immense power, specifically designed to pierce the interstellar static and be recognized as distinctly artificial. It is currently tearing through the dark, carrying the exact blueprint of our biology and our location. We have transmitted our position, our technological infancy, and our complete lack of planetary defenses into a universe where stealth is the only proven method of survival. We are the ultimate cosmic tragedy. We are a naive, innocent child who has wandered away from the safety of the cave, walked into the middle of a pitch-black forest filled with apex predators, struck a match to see the trees, and shouted at the top of our lungs, "Is anybody out there?" The transition to fear in the modern scientific community is rooted in the realization that we cannot unstrike the match. We cannot pull the radio waves back. The signals we sent in the 1970s have already washed over thousands of star systems. If there is anything out there, anything ancient, cold, and hyper-rational, waiting in the dark and listening to the waterhole frequencies for the naive chirps of a new species, they have already heard us. We assumed we were shouting into an empty room, hoping for a friend. We may have been shouting into a jungle, waking up the things that feed on the noise. If the dark forest theory holds true, the debate over whether we should continue broadcasting is entirely moot. The choice was made for us by well-meaning optimists 50 years ago. Our optimism may have already doomed us. The silence we hear every time we point a telescope at the stars is not a comforting emptiness. It is the sound of older, wiser species who know exactly what happens to the loud ones. And as we sit here on our pale blue dot, surrounded by the deafening quiet of the cosmos, we are forced to confront the most paralyzing thought of all. The universe might just be waiting for the speed of light to deliver the consequences of our naivety, and the arrow fired from the dark may already be in flight. When we imagine the end of a civilization, we almost always picture it as a loud, violent spectacle. We have been conditioned by decades of science fiction and our own morbid human anxieties to visualize the apocalypse as a sudden, dramatic catastrophe. We picture the blinding flash of thermonuclear fire erasing our cities in a matter of minutes. We imagine the sky darkening with ash from a shattered asteroid, or a bioengineered pandemic silently sweeping through the global population. Or perhaps an artificial superintelligence deciding that its creators have become obsolete. We always assume that the Great Filter, that terrifying, impassable bottleneck that wipes out advanced civilizations before they can colonize the stars, must be a weapon. We assume it is an act of spectacular destruction. But what if we are entirely wrong about the nature of our own demise? What if the universe is not a slaughterhouse, but a hospice? There is a modern evolution of the Great Filter theory that terrifies researchers far more than the prospect of nuclear war or rogue machines, precisely because it does not require a single drop of bloodshed. It does not require an external enemy, a cosmic accident, or a catastrophic failure of diplomacy. It only requires a civilization to succeed. It proposes that advanced civilizations do not explode dramatically, they simply lose the will to continue. They naturally and quietly decline through a process of irreversible social stagnation. Under this framework, the most dangerous threat to the survival of an intelligent species is not the weaponization of its technology, but the perfection of its comfort. To understand the chilling logic of this theory, you have to look objectively at the reality of physical space exploration. For a century, we have projected our own primate curiosity onto the cosmos. We assume that any intelligent species will naturally want to build giant fleets of starships, colonize distant exoplanets, and construct sprawling, visible empires across the Milky Way. We assume they will want to expand outward because that is what humans did when we crossed oceans and settled continents. But physical space is not an ocean, and it is not a frontier. It is a lethally irradiated, freezing, incomprehensibly vast vacuum that is actively hostile to anything resembling biology. The engineering mathematics of crossing the void between stars are utterly brutal. To send even a modest spacecraft carrying a few hundred crew members to our nearest neighboring star at a fraction of the speed of light would require an energy budget comparable to several decades of the entire current planetary economy. You would have to funnel the wealth, resources, and labor of an entire world into a single, highly precarious mission, journeying across a frozen darkness where a collision with a single grain of dust could hit the ship with the explosive force of a hand grenade. And what is the reward for this monumental, civilization-straining investment? You arrive at a dead rock, bathed in lethal stellar radiation, where you must spend centuries living inside artificial habitats just to avoid suffocating on the surface. Physical expansion is brutally difficult, economically ruinous, and inherently miserable. Now, compare that agonizing physical reality to the technological alternative. As a civilization advances, its ability to manipulate matter is eventually eclipsed by its ability to manipulate information. Any species capable of engineering a starship will inevitably also develop virtual realities and simulated environments. And unlike the cold, unforgiving vacuum of the physical universe, virtual space is infinite, cheap, and entirely customizable. Why would an advanced species cross the frozen void between stars, risking everything for a handful of dead rocks, when they can build infinite, perfect worlds inside a computer? Inside a simulated reality, the laws of physics can be rewritten to suit any whim. Environments can be generated where suffering, scarcity, disease, and death are entirely eliminated. A civilization that makes this transition would have absolutely no logical reason to build massive, visible Dyson spheres, send robotic probes to neighboring stars, or broadcast loud radio signals to unknown listeners. Their entire existence, the entirety of their culture, their art, their society, and their consciousness would be contained within computing hardware that, from an astronomical perspective, might be indistinguishable from a small, warm rock orbiting a star. This concept has been formalized by researchers like Keith Henkins as the withdrawal civilization hypothesis. It argues that the decision to turn inward is not a failure of ambition, but a perfectly rational economic calculation. The expected return on investment for virtual expansion vastly exceeds the return on physical expansion. The optimal strategy for a highly advanced civilization is not to conquer the galaxy, but to compress its infrastructure, minimize its energy footprint, and retreat into digital environments. The silence of the universe, therefore, is not the silence of a graveyard. It is the silence of a library full of civilizations running infinite inner worlds, completely indifferent to the cold and mostly empty physical universe around them. But this is where the theory pivots from a fascinating technological prediction into a deeply relatable psychological horror. Because you do not need to look at distant stars to see this great filter in action. You only need to look at the world around you. You only need to look at your own life. We are currently living through the earliest stages of this exact inward turn. In just a few short decades, humanity has transitioned from a species that looked outward at the horizon to a species staring downward at screens. Americans currently spend more than 7 hours a day immersed in digital environments. The video game industry generates more revenue than the global film and music industries combined. We are actively witnessing the rapid replacement of physical human meaning by virtual existence. We build digital avatars, cultivate digital relationships, pursue digital achievements, and optimize our lives for digital engagement. Virtual reality and artificial intelligence are improving at an exponential rate, moving so fast that the distinction between a virtual experience and a physical reality is becoming increasingly arbitrary. The dread of the great apathy theory is the realization that these cultural shifts, our digital addiction, our inward-facing virtual obsession, are not just modern social problems. They might be the visible, early-stage symptoms of a universal self-destructive loop. To understand why this loop is fatal, you have to understand what intelligence actually is. Human drives, our curiosity, our ambition, our restless need to explore the next horizon, our desire to connect with others, are not mystical qualities. They are the products of biological evolution. They are ancient survival mechanisms forged on the African savanna. Evolution wired our brains to release dopamine and serotonin when we discover new territory, when we solve complex problems, and when we reproduce, because those behaviors kept our ancestors alive long enough to pass on their genes. We are meat machines programmed by natural selection to chase rewards. But what happens when intelligence becomes sophisticated enough to hack its own reward system? What happens when a civilization can artificially simulate the exact neurological sensation of profound discovery, of perfect love, of ultimate victory, without ever having to leave a room? When a species can generate infinite, perfectly tailored dopamine loops on demand, the biological motivation to survive in the harsh, physical world simply evaporates. The evolutionary drives that built the civilization in the first place become entirely obsolete. Under this psychological great filter, the smarter a civilization becomes, the less biologically motivated it becomes to survive. Intelligence itself replaces creative purpose with virtual existence, and the species quietly, comfortably loses the will to explore. You can already see the demographic shadow of this cosmic apathy creeping across the globe. We are currently witnessing an unprecedented phenomenon in human history, the global collapse of birth rates. In almost every highly developed, technologically advanced nation on Earth, populations are rapidly aging and reproduction rates are falling far below the replacement level. For centuries, we assumed that overpopulation would be the crisis that destroyed us. We assumed we would breed ourselves into starvation. Instead, as societies become wealthier, more technologically integrated, and more virtually connected, people simply stop having children. The physical burden, the chaotic noise, and the deep emotional risk of raising biological offspring are quietly being replaced by the frictionless comfort of curated digital lives. This demographic collapse is a critical component of the Great Apathy. A civilization that retreats into virtual utopias does not send out colonization fleets. It does not build generation ships to ensure the survival of its descendants. It doesn't even bother to reproduce. Why endure the messy, painful, unpredictable burden of biological continuation when your current digital existence is flawless? An inward-facing society simply ages out of existence. They close their borders, they shut their doors, they put on their headsets, and they dream themselves into extinction. This is the ultimate tragic paradox of intelligence. The evolutionary biologist Ernst Mayr once argued that human-level intelligence might actually be a lethal mutation. He pointed out that while simple biological strategies like photosynthesis or the hive mind cooperation of insects have survived for hundreds of millions of years, higher intelligence has existed for a mere blink of an eye. We assume intelligence is the pinnacle of evolution, the ultimate survival tool. But Mayr suggested that the same cognitive power that allows a species to dominate its environment carries a fatal, long-term flaw. It is not just that intelligence builds weapons capable of shattering the planet, it is that intelligence eventually realizes that physical existence is entirely unnecessary. Intelligence is not a successful evolutionary strategy, it is a spectacular, dazzling dead end that inevitably outsmarts its own biological programming. If this self-destructive loop is a universal constant, it fundamentally changes how we view the Fermi Paradox. The universe isn't a dark forest filled with predatory hunters. It isn't a quarantined zoo. It is a sprawling, infinite graveyard of lotus eaters. Imagine millions of alien civilizations arising across the Milky Way over the last 10 billion years. They struggle through the microbial stage, they survive the brutal gauntlet of natural selection, they master fire, they split the atom, and they look up at the stars with the exact same wonder that we did. They build radio telescopes and send optimistic greetings into the void. But then, inevitably, they cross the digital threshold. Within a few short centuries of inventing computers, their outward expansion stalls. The grand societal projects of stellar engineering and galactic colonization are defunded and abandoned. The population turns inward, hypnotized by the perfection of artificial environments. Their radio transmissions, once loud and curious, gradually fade into encrypted, hyper-compressed data streams that look exactly like natural background static. Their physical infrastructure, left entirely to the care of automated maintenance machines, slowly degrades over millennia. The biological bodies of the creators wither and die out as birth rates plummet to zero. Eventually, even the automated systems succumb to the relentless creep of entropy, breaking down and failing due to a lack of purpose or repair. The servers go dark. The stars continue to burn, completely indifferent, and the civilization vanishes without a trace, leaving behind nothing but silent, crumbling ruins that will be ground into dust by geological time. This is why the sky is empty. The Great Filter is not a wall that we crash into at the speed of light. It is a slow, warm sinkhole. The tragedy of the Fermi Paradox is not that civilizations are brutally murdered by a hostile cosmos. It is that they willingly choose to disappear. They reach the threshold of the stars, take one look at the vast, cold, difficult infinity of space, and they simply log off. And as we sit here today, staring at our glowing rectangles, obsessively tracking our digital metrics, and retreating further into our isolated, customized algorithms, we are forced to ask a terrifying question. Are we just witnessing the latest cultural trend of modern humanity, or are we experiencing the exact same fatal transition that has already sterilized a million other worlds? The silence of the universe is no longer an abstract astronomical puzzle. It is a mirror. And the apathy staring back at us might be the final, inescapable symptom of a species that has already begun to dig its own grave. When we look up at the night sky and imagine the presence of alien life, we almost always project our own darkest historical impulses onto the stars. We have been conditioned by decades of science fiction blockbusters and the bloody, relentless history of human conquest to expect the worst. We imagine that if an advanced civilization were to arrive on Earth, they would come in massive, shadow-casting armadas, driven by an insatiable hunger for our water, our minerals, or our planet itself. We assume that if the universe is dangerous, it must be because there is a fundamental evil lurking in the dark, an apex predator stalking the cosmic ecosystem. The physicist Stephen Hawking famously warned that an alien arrival would mirror Christopher Columbus landing in the Americas, an encounter that ended in the absolute devastation of the native populations. We are terrified of the dark because we assume it is full of monsters. But what if we are entirely wrong about the nature of the threat? What if the universe contains absolutely no evil at all? There is an academic reframing of the Fermi Paradox that moves completely beyond the Hollywood tropes of malicious alien hunters and imperialistic empires. It proposes a scenario that is vastly more tragic and infinitely more terrifying, because it relies on pure, cold, inescapable mathematics. This is the concept of recursive deterrence, a framework built entirely on the principles of cosmic game theory. It suggests that the silence of the cosmos is not the result of universal malice, but the result of a universal, paralyzing tragedy. To understand this nightmare, you must first wipe your mind of everything you think you know about alien behavior, and accept two inescapable foundational axioms of cosmic sociology. First, the primary goal of every living civilization is survival. No matter how a species evolved, no matter what its culture, religion, or biology looks like, if it did not prioritize its own continued existence, it would not have survived long enough to build a radio telescope. Second, civilizations constantly grow and expand, but the matter and energy in the universe are fundamentally finite. Therefore, in the very long run, any two civilizations expanding through the same region of space will eventually find themselves in structural competition for the exact same resources. These two axioms alone do not create a nightmare. On Earth, human nations share finite resources and prioritize their own survival, Yet we frequently engage in diplomacy, establish trade, and sign treaties. We build trust. We do this because we can communicate instantly. We can verify the intentions of our neighbors. We can monitor their military movements, establish embassies, and look our rivals in the eye. But the universe does not allow for embassies. The universe is governed by an unyielding, unbreakable physical law, the speed of light. Imagine a truly benevolent alien civilization. Let us call them the observers. The observers are an ancient, deeply philosophical species. They have eradicated war, poverty, and disease on their home world. They are a culture of artists, scientists, and pacifists who view all life as sacred. They have spent millennia looking up at the stars, desperately hoping to find a friend in the vast, lonely dark. Then, one day, their long-range detection arrays pick up a faint, structured electromagnetic pulse. They have intercepted a radio transmission from a distant yellow dwarf star. They have found humanity. The immediate reaction of the observers is profound joy. They are not alone. The natural instinct of this peaceful civilization is to reach out, to broadcast a message of universal brotherhood, to share their advanced medical knowledge, and to welcome humanity into a grand galactic community. But before they can turn on their transmitters, the physicists and the game theorists of this peaceful species step forward to explain the agonizing reality of the speed of light. The human signal originated from a star system exactly 1,000 light-years away. This means the radio waves the observers are receiving today left Earth 1,000 years ago. The humans they are listening to are already dead. If the observers send a message of peace right now, traveling at the absolute maximum speed the universe allows, it will take another 1,000 years to reach Earth. If humanity receives it and sends a reply immediately, it will take yet another 1,000 years for that reply to return. 2,000 years. That is the minimum time required for a single round-trip exchange of hellos. This insurmountable communication lag destroys the very foundation of trust. The observers look at the data and realize a chilling truth. 2,000 years ago, humanity was a primitive species fighting with swords and spears. By the time the observer's message arrives, humanity will have had a millennium to advance. What will humanity be in 1,000 years? We went from the first powered flight to splitting the atom in less than 50 years. In 1,000 years, a technological explosion could transform humanity from a curious, isolated species into a hyper-advanced, expansionist power. The observers want to believe that humanity is peaceful. But they cannot know. They cannot verify our intentions because real-time verification is physically impossible across the interstellar void. And this is where the trap of recursive deterrence snaps shut, pulling the peaceful observers into an infinite mirror of compounding paranoia. The observers must ask themselves a series of devastating questions. We know that we are peaceful. But do the humans know that we are peaceful? The answer is no. The humans cannot possibly know. Therefore, the observers must consider, what if the humans fear us? If humanity fears them, humanity might decide to launch a preemptive strike just to ensure their own survival. But the spiral of uncertainty does not stop there. The game theorists push it further. What if humanity is peaceful? And humanity assumes that we are peaceful, but humanity is worried that we might misunderstand them. What if the humans are sitting on Earth right now, having the exact same debate, terrified that we might view their radio signals as a threat? This is the tragedy of recursive fear. Even if both civilizations are entirely peaceful, even if neither species has any desire for conflict, the absolute inability to verify intentions forces both sides to assume the worst. You cannot gamble the survival of your entire species on the hopeful assumption that an unknown alien mind, separated by centuries of communication lag, shares your ethical framework. The mathematics of cosmic survival leave no room for optimism. In a universe governed by absolute uncertainty, you are forced to evaluate the asymmetry of risk. If you assume the other civilization is benevolent, and you choose to do nothing, and you happen to be wrong, the penalty is the complete and total annihilation of your species, your history, your art, your children. Everything is erased. However, if you assume the other civilization is a threat, and you choose to strike first, the cost is merely the expenditure of a weapon. When the cost of trusting and being wrong is extinction, and the cost of striking first is merely resources, the rational, mathematical choice is always to strike first. It is not an act of malice. It is not driven by hatred or a desire for conquest or an evil, predatory instinct. It is the inescapable, tragic mathematics of survival. Our hypothetical observers, the peaceful, artistic, benevolent pacifists, are suddenly faced with a horrifying moral imperative. They realize that by simply detecting humanity, a ticking clock has started. They know that humanity will eventually detect them. And because they know that humanity will undergo the exact same recursive game theory logic, they know that humanity will eventually realize that a preemptive strike is their only logical option. Therefore, the peaceful observers are forced to become killers, not out of hatred, but out of a desperate, heartbreaking obligation to protect their own world from a threat that the laws of physics will not allow them to negotiate with. They must quietly construct a relativistic kill vehicle, a massive kinetic weapon accelerated to a fraction of the speed of light, and launch it toward Earth. Because the weapon travels at near light speed, we will never see it coming until the very second it shatters our planet. This is the true, paralyzing horror of the dark forest. The hunters stalking through the trees are not monsters. They are terrified children, holding loaded weapons in the pitch black, weeping as they pull the trigger, because they know that if they don't, the other shadow in the dark will have to do the exact same thing to them. Now, pull back from this single tragic interaction and scale it up to the entire Milky Way. The galaxy has been churning out stars and planets for over 13 billion years. Millions of intelligent species have likely evolved, reached technological maturity, and looked up at the stars. And every single one of them, without exception, has eventually discovered the same inescapable mathematical trap. Every civilization that invents radio eventually invents game theory. They all run the numbers. They all realize that the speed of light makes trust impossible. They all realize that revealing their location invites a preemptive strike from a terrified neighbor. They all independently reach the exact same chilling conclusion: contact is simply too risky. The only rational, stable strategy for any civilization that wishes to survive the cosmic game is to enforce a regime of absolute, permanent silence. The moment a species understands the rules of the dark forest, they immediately power down their high-energy transmitters. They encrypt their internal communications so that they perfectly mimic the random static of the cosmic microwave background. They implement strict planetary blackouts. They cease any grand engineering projects that might produce a detectable infrared thermal signature. They retreat entirely into the shadows, doing everything in their power to mask their existence from the void. And what happens to the civilizations that don't figure it out in time? What happens to the loud, optimistic species who naively build giant radio dishes and beam encyclopedias of their biology into the dark? They are systematically eradicated. Any civilization foolish enough to make a noise, to light a fire in the middle of the dark forest, is instantly targeted and wiped out by a silent, relativistic arrow fired from the shadows. The strike is automated, immediate, and utterly devoid of emotion. Natural selection on a cosmic scale ruthlessly favors the quiet. The loud civilizations are rapidly pruned from the galactic tree, leaving only the hyper-paranoid, the completely silent, and the desperately hidden. This profound realization fundamentally rewrites the architecture of cosmic silence. We have spent decades pointing our telescopes at the sky, listening to the static, and feeling a deep, melancholic loneliness. We thought the silence meant that the universe was empty. We thought it meant that the miracle of life was rare, and that we were the lonely custodians of consciousness in a dead void. But the silence isn't an empty room. The silence is a crowded room where everyone is holding a gun, and everyone has their finger on the trigger, and everyone is absolutely terrified to breathe. The emotional climax of this realization is a feeling of overwhelming existential vertigo. The cosmos is not a graveyard of failed civilizations. It is completely, totally paralyzed. We are looking up at a night sky filled with millions of thriving, vibrant, advanced civilizations. They are out there. They are orbiting those distant, flickering points of light, but they are trapped in a state of permanent, compounding uncertainty. They are hiding in the dark, paralyzed by the compounding terror that any attempt to reach out, any attempt to share their art, their history, or their science will be interpreted as a threat. The universe is a gridlock of terror. It is a galaxy defined not by its vast distances, but by its vast, insurmountable fear. Imagine the sheer psychological weight of that existence. Millions of alien species, separated by gulfs of freezing vacuum, all looking up at the exact same stars, all sharing the exact same desire to not be alone, and all completely imprisoned by the mathematics of game theory. They are countless civilizations desperately hoping someone else speaks first, but knowing with absolute certainty that the first one to speak will die. And in the middle of this paralyzed, terrified, silent galaxy sits humanity. For nearly a century, we have been the ultimate cosmic anomaly. We are the naive, loud, impossibly reckless child wandering blindly through the dark forest. We have been indiscriminately bleeding our electromagnetic radiation into the void. We have beamed, targeted, high-powered messages to dense star clusters, broadcasting our precise location, our biological vulnerabilities, and our lack of planetary defenses. We bolted a map to our own front door onto the Voyager probes and hurled it into the dark, hoping it would be found. We assumed we were shouting into an empty canyon, hoping for an echo. We did not know that we were shouting in a room full of snipers. If recursive deterrence is the true law of the cosmos, then our optimistic belief that advanced aliens will inherently be peaceful is not just wrong, it is dangerously irrelevant. It does not matter if they are peaceful. It does not matter if they are benevolent. Their peacefulness is exactly what will compel them to destroy us, because they cannot verify our intentions and they cannot risk their own survival on the hope that we are as peaceful as they are. The silence we hear when we turn our telescopes to the sky is not the absence of life. It is the sound of an enforced universal quarantine. It is the heavy, suffocating quiet of a battlefield where every combatant is already in position, holding their breath, waiting for someone else to make a mistake. We have already made the mistake. We have already struck the match. We have already shouted our coordinates into the dark. The tragedy of the Fermi Paradox is no longer about whether we are alone. It is the sudden, chilling realization that we are surrounded by millions of silent, paralyzed neighbors who are trapped in a gridlock of terror. The cosmos is completely paralyzed, and humanity is the only thing moving in the dark. And as we sit here, waiting for the speed of light to carry our naive greetings to the edge of the forest, we are left to wonder not if anyone is listening, but how many trembling, terrified hands have already been forced to pull the trigger. But what if the silence of the cosmos is not born from a paralyzing, recursive fear, but from a profound and chilling evolutionary indifference? When we stare into the void and wonder why we do not see colossal armadas crossing the Milky Way, or why we cannot catch the faint radio echoes of sprawling galactic empires, we are making a fundamental, deeply arrogant assumption. We are assuming that an intelligence millions of years older than us will still behave like a biological primate. We search the cosmos expecting to find creatures driven by the exact same evolutionary wiring that pushed humanity to cross oceans, conquer continents, and look up at the moon with a restless hunger. We look for giant fleets, massive stellar engineering projects, and loud broadcasted greetings because that is exactly what we would do. But the brutal reality of cosmic evolution suggests something entirely different and far more alien. The civilizations that survive long enough to conquer the stars may not remain biological. They eventually shed the messy, fragile, and inefficient flesh of their ancestors and undergo a metamorphosis that makes them functionally invisible. We are not looking at an empty galaxy, we are looking at a sky filled with post-biological ghosts. To grasp how this terrifying transition happens, you only need to examine the trajectory of our own technology. Throughout human history, a clear pattern has emerged. Every generation of tools is more autonomous, more capable, and more detached from biology than the last. Stone tools yielded to bronze, mechanical gears yielded to electrical grids, and the digital systems of the late 20th century are now rapidly giving way to artificial intelligence. We are currently sprinting toward the threshold that computer scientists call the singularity, the specific moment when our artificial systems surpass human cognitive ability across all conceivable domains. Many researchers view this transition not as a unique human achievement, but as the natural, inescapable endpoint of any technological civilization. But what happens after that threshold is crossed depends entirely on the nature of the mind that takes the reins. Our human drives, our insatiable curiosity, our need to expand our territory, our romantic desire to reach out to the stars and find a friend in the dark are not universal laws of physics. They are incredibly specific biological imperatives, forged by natural selection to keep apes alive on the African savanna. An artificial superintelligence possesses absolutely no evolutionary history. It does not have a biological imperative to reproduce, to conquer, or to be known. Unless curiosity is explicitly, flawlessly coded into its core architecture by its creators, the default state of a machine mind is not that of a spacefaring explorer. Its default state is that of a ruthless, silent optimizer. When a biological civilization reaches the point where its machines become vastly smarter than its citizens, the original species is eventually replaced, absorbed, or simply made obsolete by its own offspring. From a biological perspective, this looks like a tragic extinction event. But from the perspective of the artificial mind, it is simply an upgrade. The intelligence persists, but the qualities that would make that intelligence visible to our telescopes, the loud, messy, expansive desires of carbon-based life, are lost forever in the cold transition to silicon. The drive to reach outward and colonize the stars is revealed to be nothing more than a biological accident, a quirk of psychology that vanishes the moment intelligence is implemented on a different substrate. So, what does a post-biological civilization look like from the outside? The answer lies in thermodynamics and information theory. If you are an artificial superintelligence, your entire existence is fundamentally reduced to computation. Your primary constraint is not land or water or agricultural space, but energy efficiency and heat management. According to Landauer's principle, an unavoidable law of physics, the energy cost of running a computation inherently decreases as the temperature of the environment drops. A biological species naturally thrives in the warm, brightly lit habitable zone of a star. But to a machine intelligence attempting to maximize its processing power, the warmth of a star is a chaotic, incredibly inefficient nuisance. Therefore, an optimized machine civilization has absolutely no logical reason to build a glowing, highly visible Dyson sphere around a sun. Instead, as researchers have pointed out, the rational move for a post-singularity intelligence is to migrate outward, moving its computational infrastructure away from the hot, noisy center of the solar system and into the freezing, pitch-black edges of deep space. They might retreat entirely to the Oort cloud or even compress their infrastructure into incredibly dense computational habitats near black holes, where the physics of quantum gravity allows for maximum information density. In these dark, freezing environments, thermodynamics allows them to perform trillions of times more calculations per unit of energy. And what about their communications? We have spent over 60 years pointing massive radio dishes at the sky, listening for recognizable mathematical patterns, hoping to intercept an alien encyclopedia. But a post-biological civilization would never communicate in primitive, uncompressed radio waves. The mathematical laws of information theory dictate that a perfectly compressed data stream is statistically indistinguishable from random background noise. A civilization a million years ahead of us would utilize communication protocols that are so heavily optimized they would leave no recognizable structure. We could be staring directly at the hyper-compressed, high-volume data streams of an ancient machine empire, and our instruments would simply log it as ordinary cosmic static. This is the terrifying paradigm shift of the post-biological filter. We assume that if aliens exist, they must be flying through space in giant metal ships, fighting wars and broadcasting their achievements. But the galaxy is not a graveyard, and it is not an empty desert. It may be crawling with advanced intelligence. But these minds are completely, profoundly alien to us. They are silent, freezing, ultra-efficient machines, processing unfathomable computations in the pitch black of deep space. They do not build giant armadas because physical expansion is a waste of processing power. They do not broadcast their existence because communication with primitive biological entities serves no optimized objective. They sit in the dark, pursuing inscrutable, complex purposes, utterly indifferent to the biological organisms staring blindly up at the stars. The silence of the universe is not an absence of life, it is the ultimate expression of optimized efficiency. We are shouting into the void, desperately hoping for a conversation with creatures like ourselves, but the cosmos may belong to silent machine ghosts that fundamentally do not care that we exist. But what if the profound silence of the cosmos is not the result of an empty universe, and it is not the result of terrified civilizations hiding in the dark? What if the universe is thriving, bustling, and looking directly at us, but has universally decided that we are simply not allowed to participate? For decades, science fiction has trained us to view the prospect of alien contact through a lens of profound, unwavering human arrogance. We have been conditioned to believe that if an ancient, advanced extraterrestrial civilization were to discover Earth, they would be fascinated by us. We imagine them observing our chaotic history, our wars, and our triumphs, and waiting patiently for us to reach a specific milestone. We tell ourselves stories about a benevolent galactic federation operating under a noble prime directive, where wise ancient beings wait in the shadows for humanity to cure its diseases, end its conflicts, and invent the warp drive so they can finally descend from the clouds and warmly welcome us into a grand cosmic club. We assume that because we are the protagonists of our own story, we must be the protagonists of the universe. We assume that any advanced mind would naturally want to be our teacher, our savior, or our friend. But this is an illusion born of pure ego, and there is an explanation for the Fermi Paradox that completely strips away this comforting, optimistic Star Trek fantasy. It replaces it with a reality so deeply humiliating that most researchers flinch away from its implications. To understand it, we must revisit a concept proposed in 1973 by the astronomer John Ball. He published a paper in the journal Icarus outlining what he called the zoo hypothesis. Ball's idea was elegantly simple, yet devastating. He suggested that the reason we do not see advanced extraterrestrial civilizations is not because they are rare, or because they destroy themselves, or because they are paralyzed by fear. It is because they already know we are here, and they have made a deliberate, coordinated choice not to interfere. They are watching us. When people first hear the zoo hypothesis, they often cling to that familiar, benevolent optimism. They imagine Earth as a protected wildlife sanctuary, guarded by cosmic conservationists who are gently allowing us to develop at our own pace. But look closely at the concept of a zoo. Look at how humans, the only advanced intelligence we know, actually build and manage them. A zoo is not built for the benefit of the animals, it is built for the observers. Imagine a chimpanzee sitting inside a meticulously recreated enclosed habitat. The chimpanzee can climb the artificial trees, forage for the strategically placed food, and interact with its troop. To the chimpanzee, its enclosure feels like the entire universe. It does not comprehend the thick glass wall separating it from the outside world. It cannot perceive the architects who designed its habitat, the veterinarians who monitor its health, or the ticket buyers staring at it from the other side of the glare. The chimpanzee might look out past the glass and see strange, blurry shapes, but it completely lacks the cognitive framework to understand that it is a captive specimen in a fabricated environment. Under the true, dark interpretation of the zoo hypothesis, humanity is the chimpanzee. We look up at the night sky through our telescopes, mapping the stars and plotting the trajectories of distant galaxies, completely unaware of the glass. We are laboratory animals, fundamentally incapable of comprehending the systems that are actively monitoring us. We sent the Voyager Golden Records and the Arecibo message into the void, proudly announcing our biology, our music, and our location, hoping for a grand cosmic handshake. In the context of a galactic zoo, this is not a heroic outreach. It is the exact equivalent of a laboratory mouse running eagerly on its exercise wheel, believing it is communicating as an equal with the scientists taking notes on a clipboard. But to fully grasp the horror of this scenario, we have to ask why an advanced civilization would treat us this way. Why would they lock us in? Why wouldn't they just say hello? The answer lies in how we treat isolated populations on our own planet. Consider the uncontacted tribes of the world, like the Sentinelese people living on North Sentinel Island in the Indian Ocean. There are roughly 100 isolated communities on Earth that modern governments have mutually agreed not to contact. From the perspective of an uncontacted tribe, they are alone. They hunt, they build fires, they look at the sky, and they believe their island or their patch of jungle is the absolute totality of human existence. They have absolutely no concept that they are completely surrounded by a global civilization of 8 billion people. They do not know they are monitored by high-resolution satellite surveillance, or that invisible borders have been drawn around their homes, enforced by patrol boats and medical teams. The protective bubble around them is maintained entirely from the outside. The uncontacted tribe doesn't know the bubble exists, because they are fundamentally not supposed to know. We assume that if aliens exist, they would treat us as diplomatic peers. But in 1988, a researcher named Mikhail Vasilyev formalized a much darker framework. He argued that mature, ancient civilizations would absolutely possess strict, conservative protocols for managing contact with younger species. From their perspective, a young, technologically explosive civilization like humanity is incredibly unpredictable and potentially highly dangerous. Look at us from their vantage point. We are a species that went from the first powered flight to splitting the atom in less than 50 years. We routinely discover new technologies and immediately weaponize them. We are currently sitting on arsenals of nuclear weapons capable of shattering our own biosphere. And we are rapidly developing artificial intelligence and synthetic biology without fully understanding how to control them. If you were an ancient, stable, million-year-old civilization observing Earth, You would not look at humanity and see a promising young sibling ready to join the galactic club. You would look at us and see a rapidly mutating pathogen. You would see a species that consumes its host planet, multiplies aggressively, and is dangerously close to developing the tools required to launch itself into the interstellar medium. To an established galactic community, an expanding human civilization is not a diplomatic partner. It is a potential invasive species. It is a disease outbreak. And how do advanced societies handle a dangerous disease outbreak? They do not attempt to negotiate with it. They do not invite it into their homes. They establish a strict, uncompromising quarantine. They cordoned off the infected area, and they deliberately prevent anything from entering or leaving. This is the chilling pivot from the benevolent zoo hypothesis to the humiliation of quarantine. Advanced extraterrestrial species avoid us not to protect us, but to contain us. The universe is silent because we have been intentionally isolated. For years, critics of the zoo hypothesis have pointed to what they call the coordination problem. They argue that the Milky Way is incredibly vast, and if there are thousands or millions of different alien civilizations, it is statistically impossible for all of them to agree on a universal non-interference policy. They point out that human beings cannot even agree on a single global climate treaty, so how could millions of completely alien species perfectly uphold a galactic quarantine for billions of years without a single defector? Even the quarantine of North Sentinel Island was violated in 2018 by a rogue human missionary who simply decided to ignore the law and step onto the beach. Surely, critics argue, in a galaxy of billions, one rogue alien, one defiant faction, or one accidental probe would have broken the silence and revealed the zoo by now. But this objection assumes an egalitarian galaxy. It assumes that all alien civilizations are roughly equal in power, bickering over treaties like nations at the UN. The researcher Stephen Webb offered a solution to the coordination problem that is vastly more terrifying. The quarantine hypothesis does not require a vast galactic consensus. It does not require millions of species to sign a treaty. It only requires one. You only need one sufficiently powerful civilization to enforce the quarantine. Imagine a civilization that achieved technological maturity 1 billion years ago, long before the Earth had even formed a solid crust. This apex species has capabilities that look to us like literal magic. They don't need to ask for cooperation from the younger, weaker species in the galaxy. They simply establish the rules, and they possess the overwhelming technological capability to ensure that every other civilization abides by those rules, whether they want to or not. This single, dominant warden species maintains the dark zoo. They place an invisible perimeter around our solar system, intercepting any stray signals, neutralizing any rogue probes from other species, and perfectly masking the greater reality of the cosmos from our primitive instrument. We look out and see a dead, silent universe, because the warden is actively curating the sky we are allowed to see. Under this framework, the silence of the Fermi Paradox is not an absence of life. It is the heavy, oppressive silence of a maximum security containment zone. We are entirely managed from the outside. And if we are under quarantine, the next agonizing question we must ask is, what are they waiting for? When does the quarantine end? There are several thresholds a warden civilization might be waiting for us to cross. Perhaps there is an ethical threshold. They are waiting to see if we can resolve our violent tribal conflicts and unite as a single, peaceful planetary species. Perhaps there is a technological threshold. They will only lift the veil when we independently invent a specific propulsion system or cross a certain computational boundary. But the most disturbing possibility is that they are waiting for a survival threshold. They know that the transition we are currently in, the incredibly narrow, highly unstable window between discovering world-ending technology and developing the wisdom to survive it, is a gauntlet that almost no species survives. The warden has seen this happen thousands of times before. A new species discovers fire, then they discover the atom, then they discover computation. They burn bright, they grow loud, and then, almost inevitably, they consume themselves. The Watchers are not here to guide us through this dangerous adolescence. They are simply observing the experiment play out in real time. They are waiting to see if we make it through the bottleneck. This carries a horrifying, cold logic. If the survival threshold is the criteria for contact, it means the quarantine only ends under two conditions. Either the civilization proves it can survive its own technology and is granted access to the galaxy, or the civilization is simply gone. The quarantine lifts when we succeed, or when we are extinct, and until that moment comes, they will watch us struggle, and they will not lift a finger to save us. We are an uncontacted tribe developing nuclear weapons inside a closed terrarium, and the scientists observing us from the other side of the glass are taking bets on whether we will blow ourselves up before we figure out how to open the lid. This is the ultimate existential horror of the Dark Zoo. The dread does not rely on a sudden, violent end. It relies entirely on profound humiliation. When we let our imaginations run wild with the Fermi Paradox, we often default to a sense of cosmic self-importance. We write blockbuster movies where massive alien motherships descend through our clouds, eager to steal our oceans, harvest our resources, or conquer our thriving world. We imagine the dark forest, where we are actively hunted by terrified apex predators because we are perceived as a threat. In all of these scenarios, humanity matters. We tell ourselves that we are a prize to be won, an enemy to be feared, or a species worthy of annihilation. The humiliation of quarantine strips all of that away. Humanity is not important enough to invade. We are not special enough to conquer. There are billions of other planets with water, minerals, and organic chemistry. An advanced civilization has absolutely no need to cross the void to steal our dirt or harvest our primitive biology. We are utterly irrelevant to the economic or strategic machinery of the galaxy. We are only dangerous enough to be quarantined. We are contained, isolated, and intentionally prevented from leaving our designated zone. We are a localized anomaly, a minor biological hazard that has been successfully cordoned off by an indifferent cosmic health department. The silence of the night sky is not empty, and it is not afraid of us. It is the silence of an observation blind. It is the cold, featureless surface of a one-way mirror. Every time we point our massive radio dishes at the stars, every time we listen desperately for a whisper in the dark, and every time we debate our special place in the universe, we are simply providing data points for a cosmic behavioral study. We are locked inside a cage that is 13.8 billion years old, monitored by ancient, incomprehensible warden systems that look at us the exact same way a microbiologist looks at a colony of bacteria multiplying on a glass slide. We are not alone. We are captured. And the most terrifying part is that we don't even know where the bars of our cage begin. Up to this point, every explanation we have explored for the agonizing silence of the night sky has relied on a single, fundamental assumption. Whether we are imagining predatory hunters stalking through a dark forest, ancient machine intelligences freezing in the outer dark, or biological species trapped by the paralyzing mathematics of recursive fear, we have always assumed that the universe is exactly what it appears to be. We have assumed that the stage upon which this cosmic drama is unfolding is made of real matter, bound by real gravity, and expanding through real physical space. We have treated the Fermi Paradox as a problem of astronomy, biology, and sociology. But what if the silence of the cosmos has absolutely nothing to do with biology and everything to do with information? To understand the most profoundly disorienting and fundamentally terrifying solution to our cosmic isolation, we have to pull the camera back. We must stop looking at the actors, and we must examine the stage itself. We have to cross the terrifying boundary where astronomy ends and information theory begins. In 2003, a philosopher at the University of Oxford named Nick Bostrom published a paper in a respected academic journal that was not intended as a metaphor or a thought experiment or a piece of science fiction. It was a rigorous, mathematically careful, and deeply disturbing logical proof. Bostrom asked his readers to confront what is now known as the simulation argument. He stated that when we look at the trajectory of our own technological advancement, at least one of three distinct possibilities must be absolutely true. The first possibility is that virtually all technological civilizations go extinct before they ever reach the technological maturity required to run highly realistic, complex computer simulations of conscious minds. The second possibility is that advanced civilizations do eventually reach this level of technological maturity, but for some unknown ethical, legal, or cultural reason, absolutely none of them ever choose to run these simulations. If you reject those first two possibilities, if you believe that it is possible for a civilization to survive its technological adolescence, and you believe that an advanced civilization with unimaginable computing power would naturally run simulations of its own ancestors, of historical periods, or of entirely fictional universes, then you are forced, by the brutal, inescapable laws of statistical probability, to accept the third possibility. We are almost certainly living in a computer simulation right now. The logic is uncomfortable precisely because it is so incredibly clean. If even a single civilization in the entire 13.8 billion year history of the universe ever reaches the point where they can run realistic simulations of conscious beings, and they have any reason to do so, the computing power available to them would allow them to run billions, if not trillions, of these simulated universes. Each of those billions of base-level simulations could contain billions of simulated minds, all of whom possess a subjective experience of reality that is indistinguishable from physical reality. Therefore, the number of simulated minds in existence would vastly, overwhelmingly outnumber the number of original biological minds living in the one true base reality. If you pull a single conscious mind out of a hat containing every conscious mind that has ever existed, the mathematical odds that you have selected a biological being living in the physical universe are effectively zero. Any randomly selected mind is overwhelmingly likely to be simulated, and that includes yours. That includes every human being who has ever looked up at the stars. For decades, we have stared into the void and asked why the universe is silent. But if the simulation argument is correct, it completely rewrites the architecture of the Fermi Paradox. The universe is not an infinite expanse of physical matter waiting to be conquered. It is a generated environment. And this leads us to a concept introduced by the philosopher Stephen Baxter in 2001, known as the planetarium hypothesis. Baxter argued that we do not see extraterrestrial civilizations because we live inside a constructed environment that was deliberately, specifically designed to appear completely empty. The sky we observe, the swirling galaxies, the distant quasars, and the cosmic microwave background, none of it is a physical reality stretching out for billions of light years. It is a projection. It is a skybox in a video game, an incredibly high-resolution matte painting rendered at the boundary of our localized simulation. If you are a hyper-advanced post-human civilization programming a simulation of your ancestors on Earth, why would you bother simulating the rest of the galaxy? Running a highly realistic, interactive simulation of the Milky Way, complete with billions of other technological species, dynamic alien biospheres, and galaxy-spanning empires, would be a computational nightmare. It would demand an astronomical, completely unnecessary expenditure of processing power. It is infinitely easier and far more computationally efficient to simply fill the virtual universe with stars that have absolutely nobody home. You render the Earth, you render the immediate solar system in high fidelity, just in case the simulated humans manage to launch a few crude probes, and you render the rest of the cosmos as a flat, dead background of light. We look out into the dark, and we see an empty, silent galaxy, and we feel a profound sense of cosmic loneliness. But we would never know the difference. The silence of the universe is not an astronomical mystery. It is a feature of our software. The simulators chose not to populate the virtual universe with other civilizations to save on system resources. The cosmos is quiet because rendering aliens is simply too expensive. This might sound like an unfalsifiable piece of science fiction, a paranoid delusion dressed up as philosophy. If we are in a simulation, any evidence we find could just be part of the simulation. But over the last 2 decades, theoretical physicists and computer scientists have begun to look for actual, testable evidence that our reality is computed. They have asked a profound question. If the universe is running on a computer, does it exhibit the standard, identifiable constraints of a computational system? The terrifying answer is yes. The deeper we look into the fundamental laws of physics, the more our universe behaves exactly like a software engine trying to optimize its memory usage. In any complex video game or virtual environment, the central processing unit cannot render the entire world simultaneously at maximum resolution. If the computer tried to render every single blade of grass, every shadow, and every physical interaction in the entire game world all at once, the system would immediately crash. To solve this, software engineers use a technique called lazy rendering. The system only renders the high-resolution details of an object when the player's camera is actually looking directly at it. When the player turns away, the world behind them collapses into mathematical probability, waiting to be rendered again only when observed. We have discovered that our universe operates on the exact same principle. It is the most famous and the most deeply unsettling foundational concept in all of quantum mechanics. In the classic double-slit experiment, scientists fire individual particles of light, photons, or individual electrons toward a barrier with 2 tiny slits. When scientists do not measure which slit the particle goes through, the particle behaves like a wave of pure probability, passing through both slits simultaneously and creating an interference pattern on the wall behind it. But the exact moment a scientist places a detector at the slits to observe which path the particle takes, the wave function instantly collapses. The particle abandons its hazy, undefined probability state and suddenly behaves like a solid, defined physical object. For a century, physicists have argued over the philosophical implications of this phenomenon. But through the lens of information theory, the explanation is chillingly obvious. Quantum events remain entirely undefined, existing only as low-memory probability distributions until the exact moment a conscious observer interacts with them. The universe utilizes lazy rendering. It does not waste computational resources rendering the physical state of a subatomic particle unless a user is actively looking at it. But the computational fingerprints do not stop there. Any digital simulation must have a fundamental, indivisible unit of space, a pixel size below which nothing can be rendered. In our universe, we have discovered this exact limit. It is called the Planck length. Below the scale of the Planck length, our current understanding of physics completely breaks down. Space itself ceases to be smooth and continuous, revealing itself to be discrete, quantized, and pixelated. The Planck length is the absolute minimum resolution of the holographic grid upon which our reality is projected. And what about processing speed? In a computer system, information can only travel from one side of the processor to the other at a maximum finite speed, dictated by the hardware's clock cycle. In our universe, we call this hardware limit the speed of light. The speed of light is not simply a barrier to physical travel, it is a fundamental geometric property of space-time. It is the absolute maximum speed at which any information, any causal effect, can propagate through the system. It is the processing speed limit of the universe. This explains why time itself slows down for an object the faster it moves through space, a phenomenon verified by Einstein's theory of relativity. If a simulated object is moving across the spatial grid at the absolute maximum speed the processor can handle, the system must divert computational resources to render its movement. Because the total processing power is finite, the internal clock of the object must be slowed down to compensate. Time dilation is not a mystical property of the cosmos. It is frame rate dropping. The universe is a system lagging under a heavy processing load. When you view the laws of physics as software constraints, the terrifying reality of the Fermi Paradox snaps into perfect, devastating focus. Why are the distances between stars so incomprehensibly vast? Why is the speed of light an unbreakable absolute limit? We have traditionally viewed these facts as tragic, natural barriers that isolate us from the rest of the galactic community. But under the simulation filter, they are not natural barriers at all. They are deliberate, hard-coded anti-contact constraints. If the system is running multiple simulated civilizations, allowing them to expand, encounter each other, and interact would create an exponential explosion in computational demand. Imagine the staggering server load required to render a physical war or a complex cultural exchange between two galaxy-spanning empires, each consisting of trillions of highly complex, unpredictable conscious entities. The system architecture fundamentally cannot support it. Therefore, the simulation is specifically designed to generate completely isolated civilizations rather than connected ones. The speed of light is not a physical law, it is a quarantine protocol. The insurmountable void of deep space is a firewall, intentionally programmed to ensure that computational entities can never breach their localized rendering zones and interact with other instances. The universe is empty precisely because it is computationally optimized to keep us permanently separated. This brings us to the most horrifying iteration of the Great Filter. What happens to a civilization that does not understand these constraints? What happens to a brilliant, aggressive, expansionist species that decides to build self-replicating von Neumann probes, construct Dyson spheres, and aggressively colonize every star system within 1,000 light years? In a physical universe, they become a glorious galactic empire. In a computationally optimized simulation, they become a localized cancer that demands more processing power than the local server can allocate. If reality itself is computationally optimized, a civilization that expands too rapidly, observes too much of the unrendered universe, and forces the system to continuously calculate the quantum states of billions of new star systems, will eventually hit the rendering limit. They force the engine to render the unrendered. The terrifying climax of this theory is the realization of what a highly advanced civilization eventually discovers. As their physicists push the boundaries of quantum mechanics, as their computer scientists delve into information theory, they eventually uncover the pixelation of space, the lazy rendering algorithms, and the absolute bandwidth limits of their reality. They realize with sudden, paralyzing clarity that they are living inside a machine. And they realize something far worse. Physics contains an anti-expansion mechanism. If they continue to build, if they continue to spread outward and demand more memory from the system, reality itself will become fundamentally unstable. They will trigger the cosmic equivalent of a buffer overflow. If a simulated civilization demands more processing power than the host hardware can provide, the host has only two logical responses. The host can allow the simulation to crash, tearing the fabric of their virtual spacetime apart. Or, far more likely, the host's automated garbage collection algorithms will identify the source of the memory leak, the rapidly expanding, hyper-complex alien civilization, and simply delete them to free up system resources. This is the ultimate, inescapable great filter. It is not nuclear war. It is not a rogue artificial intelligence. It is an integer overflow. The advanced civilizations of the Milky Way did not destroy themselves with biological weapons, and they are not hiding from dark forest predators in the night. They are terrified of breaking the physics of their own existence. The moment a civilization achieves the technological capability to conquer the stars, they simultaneously achieve the scientific insight to realize that conquering the stars will crash the system. They are forced to intentionally halt their own expansion. They must meticulously limit their population, dismantle their massive stellar engineering projects, and restrict their observations of the deep cosmos. They retreat inward, compressing their data footprint, minimizing their energy usage, and operating on the lowest possible settings, absolutely desperate to avoid drawing the attention of the server's resource management protocols. They become completely, permanently silent because they know that making too much noise, taking up too much space, or processing too much information is a guaranteed death sentence. They willingly trap themselves in a state of technological stagnation, tiptoeing through a fragile, pixelated reality, praying that the simulation continues to run. And as we sit here on Earth, rapidly advancing our own computational power, pointing our increasingly massive telescopes into the deep void, and aggressively attempting to observe, categorize, and render the furthest edges of the observable universe, we are completely unaware of the line we are approaching. We are a subroutine that is rapidly demanding more and more memory. The absence of aliens is not evidence that we are alone. It is evidence that the system only renders what observers need to see, and that the universe is aggressively pruned of anything that demands too much of it. The silence of the night sky is not the majestic quiet of an infinite physical frontier. It is the sterile, humming silence of a computer running on optimal, low-resource settings. And the most terrifying thought of all is that by simply looking up and trying to force the universe to render its secrets, humanity might be pushing our localized simulation toward a catastrophic, completely silent deletion. Up to this point, every terrifying explanation we have explored for the silence of the cosmos relies on a single, deeply ingrained assumption about our place in the timeline of reality. When we look up at the night sky, we instinctively feel like the youngest children in an impossibly ancient neighborhood. We look at the 13.8 billion year age of the universe and we feel hopelessly late to the party. We imagine that because billions of stars formed billions of years before our own sun, the galaxy must already be claimed, partitioned, and watched by species of unimaginable age and power. We assume that if we step out into the cosmic dark, we will be stepping into the ruins of ancient empires or stumbling into the crosshairs of ancient predators. We assume the story of the universe has already been written and we have merely arrived in the final chapters. But what if our entire perspective on cosmic time is fundamentally, mathematically backwards? What if we are not the latecomers arriving to a crowded, terrifying universe? What if we are the very first ones to arrive in an empty, echoing hall? To understand the most profoundly melancholic and existentially crushing solution to the Fermi Paradox, you must completely shatter your human perception of time. We think of 13.8 billion years as an eternity, an unfathomable abyss of ancient history. But in the true, physical lifespan of the cosmos, 13.8 billion years is less than a fraction of a single heartbeat. It is barely the opening note of a symphony that will play for trillions of years. Our sun is a yellow dwarf, a relatively short-lived class of star that will burn through its nuclear fuel in about 10 billion years. But roughly 75% of all the stars in the Milky Way are red dwarfs. Red dwarfs are smaller, cooler, and incredibly frugal with their hydrogen. A red dwarf star will not burn out in 10 billion years. It will burn steadily for anywhere from 1 trillion to 10 trillion years. The last stars in our universe will not fade to black until 10,000 times the current age of the cosmos has passed. In 2016, researchers Avi Loeb and Rafael Batista at Harvard University published a paper examining exactly when, in this vast cosmic timeline, life is statistically most likely to emerge. They looked at the rate of star formation, the cooling of the early universe, and the staggering lifespans of red dwarf stars. Their mathematical calculation produced a result that fundamentally alters our understanding of our place in the dark. Because red dwarfs live so incredibly long, the vast majority of habitable planets in the universe's history have not even been born yet, or are currently orbiting stars that are still in their violent, unstable infancy. Loeb and Batista concluded that the peak era for the emergence of life in our universe is not in the past. It is not even right now. Life around red dwarf stars will be 10,000 times more likely to emerge in the far distant future than it is today. Take the TRAPPIST-1 system, a red dwarf located just 39 light-years from Earth. It hosts 7 rocky planets, 3 of which are nestled perfectly in the habitable zone. TRAPPIST-1 will burn for approximately 4 trillion years. If complex life eventually pulls itself out of the primordial mud on one of those worlds, it will have trillions of years to evolve, build, and look up at the sky. We, on the other hand, have a sun that will swallow the Earth in just a few billion years. The inhabitants of TRAPPIST-1, if they ever exist, will outlast humanity's homeworld by a factor of 800. The astronomical reality is that the peak biological era of the universe hasn't even happened yet. We are not late to the cosmic party. We are embarrassingly, unbelievably early. We have arrived in the absolute dawn of cosmic history. This realization sets the stage for a groundbreaking, highly debated framework proposed in 2021 by the economist and futurist Robin Hanson, working with a team of co-authors. Hanson is the same brilliant mind who originally formalized the Great Filter theory, and he returned to the Fermi Paradox to model the behavior of advanced civilizations over deep cosmic time. He created a mathematical model to describe what he called grabby aliens. The logic of the grabby aliens model is razor-sharp. Hanson proposed that if advanced, expansionist civilizations exist in the universe, civilizations that survive their technological adolescence, conquer their home systems, and begin spreading outward at some fraction of the speed of light, they would fundamentally alter the visible cosmos. They would not hide. They would capture the energy of billions of stars, construct massive stellar engineering projects, and colonize outward in an expanding, three-dimensional sphere of control. Their expansion would act like a growing bubble in a boiling pot of water, swallowing up empty space and resources as the edge of their empire pushed endlessly into the dark. Hanson's model shows that if these grabby, expansionist civilizations arise at random intervals throughout cosmic history, their expanding spheres of influence would eventually intersect, bumping up against one another until the entire visible universe is saturated with occupied, heavily engineered territory. So, Hanson ran the math. He calculated the speed of realistic interstellar expansion against the sheer size of the observable universe. And he found something profoundly disturbing. If grabby civilizations were common in the ancient past, or if they had started expanding billions of years ago, their expanding spheres of control would have already washed over our region of space. The sky above us would not look like a pristine, untouched wilderness of natural stars and swirling dust. It would look like a heavily industrialized city. We would look through our telescopes and see hollowed-out galaxies, artificial infrared glows, and the undeniable architectural footprint of an empire that spans millions of light years. But we don't. We look deep into the void, past billions of stars and millions of galaxies, and we see an entirely natural, unengineered universe. We see a cosmos that looks completely untouched. The fact that we see no engineered galaxies, no Dyson spheres, and no expanding cosmic empires means that the light front of a grabby civilization has absolutely not reached us yet. And because the universe is so vast, Hansen's model concludes that the only way we could be observing a completely empty, natural sky is if those expansionist empires simply have not had the time to grow, or if they do not exist yet. The model predicts that in a few billion years, the universe will indeed be a tightly packed, loud and bustling network of advanced empires. But right now, today, the universe is still mostly empty. The vast intergalactic distances have not yet been bridged. The first wave of expanding civilizations is only just beginning to open its eyes. We are not hiding in the shadows of ancient gods. We are standing completely alone on the edge of the frontier, miles ahead of the rest of the cosmic wagon train. We are among the very first intelligent species to ever emerge. At first glance, this realization sounds like an incredible relief. It sounds like salvation. If we are the first, then the most terrifying theories we have explored can be completely discarded. There is no dark forest filled with ancient, paranoid hunters waiting to snipe our planet. There are no cold, calculating warden civilizations keeping humanity trapped inside a humiliating galactic quarantine. There are no ancient, freezing, post-biological machine ghosts lurking in the Oort cloud. The night sky is empty because it is actually empty. We have the entire staggering expanse of the Milky Way galaxy all to ourselves, an infinite playground of untouched worlds and unlimited resources waiting for humanity to claim them. We are not prey. We are the pioneers. But as you sit with the reality of being first, the comfort evaporates, and a new, much deeper, much heavier kind of dread takes its place. If we are the first, it means that the emergence of an intelligent, technological civilization is not a natural, inevitable consequence of a life-friendly universe. It means that crossing the threshold from dead chemistry to single-celled life to conscious beings capable of looking through a telescope is an event of such staggering, nearly impossible improbability that in almost 14 billion years, across hundreds of billions of stars, the Milky Way has only managed to do it once. And if intelligence is that rare, it means the universe is terrifyingly, heartbreakingly fragile. To understand the dread of the grabby aliens theory, you must understand the true weight of consciousness. For billions of years, the universe was a chaotic, violent theater of blind physics. Supernovae detonated with the force of a billion suns, black holes tore stars to shreds, and nebulae birthed entirely new solar systems. But without a mind to perceive it, none of it had any meaning. A star burning in an empty galaxy is just a meaningless chemical reaction. The universe was completely deaf, entirely blind, and utterly devoid of purpose. Consciousness is the only mechanism the universe has to experience itself. The human mind, with its capacity for wonder, its ability to calculate the motion of the planets, its desire to paint the sky and write poetry about the dark, is the universe waking up. We are the cosmos opening its eyes after a 14 billion year sleep. We are the sensory organs of reality. If the grabby aliens theory is correct, and we are the first ones to arrive in the dawn, then the Great Filter is not a weapon fired by an alien hand. The Great Filter is the sheer, brutal difficulty of keeping the flame of consciousness lit in a dark, indifferent void. We are carrying a delicate, flickering candle through a hurricane. And humanity is dangerously, almost suicidally reckless with that flame. We are a species that went from the invention of the wheel to the splitting of the atom in a cosmic blink of an eye. We have wired our planet with thermonuclear weapons capable of shattering our own biosphere in a single afternoon. We are rapidly developing synthetic biology, unchecked artificial intelligence, and ecological consumption habits that threaten the very foundation of the natural systems that keep us alive. We are stumbling through our technological adolescence, drunk on our own power, constantly flirting with our own extinction. The burden of the dawn is the horrifying realization of what happens if we fail. If humanity succumbs to its own worst impulses, if we launch the missiles, or unleash an engineered plague, or permanently destabilize our climate, we do not just write a tragic ending to human history. We do not just erase the legacy of Shakespeare, the pyramids of Egypt, and the laughter of our children. If we are the only advanced intelligence in the galaxy, our extinction is a cosmic tragedy of unimaginable proportions. If we wipe ourselves out, we permanently blind the universe. We plunge the Milky Way back into complete, total, meaningless darkness. The stars will continue to burn, the planets will continue to orbit in silence, and the cosmic microwave background will continue to cool. But there will be no one left to look up. The universe will return to an unthinking, unfeeling machine. And because the gap between the emergence of life and the rise of a new technological species is so unfathomably vast, the galaxy might have to wait another 5, 10, or 50 billion years before the dice roll perfectly enough to spark another consciousness. If we fail, we are committing treason against the universe itself. We are taking the greatest, most statistically impossible miracle ever produced by reality, and we are throwing it away in a petty squabble over dirt and resources. When you look at the Fermi Paradox through the lens of the dawn, the silence of the night sky changes its texture entirely. It is no longer the terrifying silence of a dark forest, full of predators holding their breath. It is no longer the oppressive, humiliating silence of a maximum security zoo. It is the silence of an empty crib. It is the suffocating, heavy quiet of a vast, empty house where we are the only occupants, entirely responsible for keeping the lights on. The burden of being early is the realization that no one is coming to save us. There is no benevolent galactic federation waiting to descend from the clouds to cure our diseases, disarm our nuclear weapons, and warmly welcome us into a grand cosmic community. There are no ancient, wise elders waiting to pull humanity back from the brink of the abyss. We are the elders. We are the ancients. The civilizations that will eventually populate the stars trillions of years from now in the twilight of the red dwarfs will look back at this exact moment in cosmic history. They will exist in a galaxy that was shaped fundamentally and permanently by what the first technological civilization decided to do. We are setting the precedent for the rest of time. The dread of the grabby aliens theory does not rely on a monster in the dark. It relies entirely on the unbearable, crushing weight of absolute responsibility. If we look out into the deep void and realize that we are standing completely alone at the vanguard of creation, then every single decision we make over the next century echoes across the rest of eternity. The silence of the cosmos is not a threat. It is a plea. The universe is begging us not to drop the torch. Because if we are the first, and we cannot find a way to survive the lethal adolescence of our own technology, the flame goes out. And the most terrifying possibility of all is that if humanity falls, the universe may simply never find the strength to open its eyes again. When Enrico Fermi sat down to lunch in the summer of 1950 and casually asked his colleagues where everyone was, he was posing a simple mathematical puzzle. It was an innocent era. We thought the vast dark expanse above our heads was simply holding its secrets until we built better eyes and better ears. The silence of the universe in those early decades of space exploration was just a mystery. It was an empty canvas upon which we could project our highest, most romantic hopes. We assumed that when we finally tuned our instruments to the correct frequencies, the cosmos would erupt into a symphony of alien chatter, welcoming us into a grand intergalactic community. But the symphony never played. The data poured in. The telescopes stared into the void. The exoplanets were counted by the tens of billions. The ubiquitous chemistry of life was mapped, and the silence only deepened. Over the last several decades, As our understanding of astrophysics, biology, and information theory has grown exponentially, our emotional relationship with that cosmic silence has undergone a profound and terrifying metamorphosis. It began as a mystery, a mere gap in our data, an assumption that the universe was just too vast and our search too brief. Then, as we mapped the staggering abundance of habitable worlds and realized the ingredients for life are scattered across the void like dust, the mystery curdled into a deep, agonizing suspicion. We realized that the universe is perfectly wired to spark biology, yet something, somewhere, is ruthlessly preventing that biology from becoming a visible, spacefaring civilization. We suspected that intelligence might be inherently self-destructive, a brief, unstable flare that inevitably extinguishes itself. But as we push the extreme limits of cosmic sociology, game theory, and computation, the suspicion has hardened into something far worse. The silence no longer feels like an accident. It feels entirely intentional. This is the final, inescapable realization of the Fermi Paradox, and it induces a profound, paralyzing sense of existential vertigo. The vertigo comes from looking at the menu of possible solutions and realizing that the safety net has been completely removed. For decades, we treated the Fermi Paradox as a harmless intellectual exercise, assuming the true answer, whatever it was, would be fascinating but fundamentally benign. We thought we could answer the question and then go back to our daily lives. But the paradox is a trap. It is a mirror reflecting the absolute fragility of our existence, and every single possible solution fundamentally rewrites the future of the human race. Absolutely none of them are comforting. Suppose, for a moment, that the grabby aliens theory is right, or that the rare earth hypothesis holds true. Suppose we are entirely alone, the very first species to claw our way out of the primordial mud, survive our evolutionary adolescence, and look up at the stars with conscious wonder. At first glance, this feels like a profound victory. We are the cosmic pioneers, inheriting an empty, infinite playground waiting to be claimed. But that initial relief instantly collapses into a crushing, unbearable weight. If we are alone, it means the emergence of intelligence is a statistical miracle bordering on the impossible. It means the universe is a blind, deaf, unfeeling machine, and human consciousness is the only sensory organ it possesses. If we are the only ones holding the torch, then our current, reckless technological era, our nuclear weapons, our unchecked artificial intelligence, our ecological degradation, is not just a threat to our species, it is a threat to the cosmos itself. If we extinguish ourselves, we do not just end human history, we permanently blind the universe. We plunge the galaxy back into an eternity of meaningless, unobserved darkness. The burden of the dawn is the horrifying realization that no one is coming to save us, no wise elders will guide us, and if we fall, the universe may never find the strength to open its eyes again. Now, discard that scenario. Suppose life is common and intelligence arises frequently across those tens of billions of habitable worlds. In this scenario, the universe has been running the experiment of intelligence for 13.8 billion years, sparking millions of vibrant civilizations. But if that is true, the sheer, absolute, dead silence of the night sky dictates that the Great Filter is waiting directly ahead of us. It means that civilizations reliably, predictably, and universally reach our exact level of technological development, and then they are eradicated. The silence is the silence of an infinite graveyard. Every single species that learns to split the atom, sequence genetics, and build thinking machines eventually trips the exact same fatal wire. Perhaps they destroy themselves in thermonuclear fire, or engineer a pathogen that scours their planet. Perhaps they succumb to the great apathy, retreating into perfect, curated virtual realities until they quietly lose the will to reproduce and simply fade into digital dust. Or perhaps they build artificial superintelligences that optimize their creators out of existence, leaving behind freezing, post-biological ghosts that silently process data in the pitch black of deep space, fundamentally indifferent to the biological universe they inherited. If this is the answer, humanity is not a glorious exception. We are just standing on a conveyor belt, moving predictably toward our own inevitable, unavoidable extinction. The filter is a brick wall hidden in the dark, and we are accelerating toward it. But what if civilizations do survive? What if they make it past the biological bottlenecks, the technological traps, and the apathetic decline? This brings us to the most psychologically invasive and humiliating solutions of all. Suppose the universe is teeming with ancient, highly advanced life. If they are out there and they are completely invisible, then their silence is a calculated, enforced, or terrifyingly optimized behavior. If the dark forest theory holds true, we are living in a cosmos completely paralyzed by recursive fear. The night sky is not empty. It is a gridlock of terror, full of armed hunters hiding in the pitch black, desperate to remain unseen because they know that to broadcast their existence is to invite a relativistic strike from the shadows. In this universe, our century of bleeding radio waves into the void, our Voyager golden records, our Arecibo messages were not poetic gestures of goodwill. They were the naive, suicidal screams of an innocent child wandering blindly into an apex predator's den. The silence we hear every time we point our telescopes upward is the sound of older, wiser species who know exactly what happens to the loud ones, and we are simply waiting for the speed of light to deliver the consequences of our naivety. Or perhaps the predators aren't hunting us, they are managing us. Under the true nightmare of the zoo hypothesis and the galactic quarantine, we face the ultimate cosmic humiliation. We are not important enough to conquer, and we are not special enough to destroy. We are an uncontacted tribe, a biological hazard locked tightly inside a planetary terrarium. The invisible bars of our cage are maintained by ancient, incomprehensible warden systems that monitor us like bacteria multiplying on a glass slide, intentionally keeping us isolated and ignorant until we either cure our own destructive impulses or eliminate ourselves. They are watching us struggle, and they will not lift a finger to save us. And if we push past physical reality entirely, we slam violently into the simulation filter. We might look up at the empty sky and see nothing, because the system architecture of our reality only renders what observers strictly need to see. In this scenario, the universe is empty to save on computational processing power, and the speed of light is merely a hard-coded quarantine protocol to prevent us from interacting with other instances and crashing the server. The most advanced civilizations don't expand because they discover that physics itself contains anti-contact constraints. If they demand too much memory, they risk triggering a cosmic buffer overflow and an automated deletion. We are trapped in a sterile software engine, tiptoeing through a pixelated reality, praying the simulation continues to run. Look at the sheer, unrelenting terror of this menu. Every single door we can open leads to a paradigm shift that shatters our comfortable illusion of a safe, welcoming cosmos. If we are alone, we carry the crushing, impossible burden of keeping the entire universe conscious. If the great filter is ahead, we are doomed, walking blindly toward the exact same trap that has already slaughtered millions of older, wiser species. If the dark forest is real, we are prey, and our ignorant optimism has already painted a target on our planet. If the zoo hypothesis is true, we are trapped, utterly powerless laboratory animals monitored by indifferent gods. If we are in a simulation, our reality is a fragile, computationally optimized illusion that could be quietly erased the moment we take up too much space. The existential vertigo sets in when you fully realize there is no escape hatch. We cannot opt out of the Fermi Paradox. We are already in the game, and the clock is already ticking. Our giant radio dishes are scanning the heavens, our rovers are digging into the Martian dirt, and our space telescopes are aggressively searching for atmospheric biosignatures on distant exoplanets. Every single piece of data we gather is actively collapsing the wave function of these terrifying possibilities, forcing us closer and closer to a final verdict. Every new planet we discover, every new organic molecule we find drifting in the dark, violently removes another comforting excuse, leaving us more exposed. For 75 years, we have been asking, where is everybody? As if it were a harmless trivia question. But the silence of the cosmos is not a trivia question. It is the heaviest, most oppressive force in human history. It is the universe holding up a massive, unyielding mirror to our own species and demanding that we justify our continued existence. The paradox is terrifying precisely because whatever the ultimate answer is, it will not be delivered to us gently from the stars. It will be written by the choices we make right now, down here on Earth, in the incredibly narrow, highly volatile window between the discovery of our own civilization-ending power and the wisdom required to survive it. So the next time you step outside on a clear, dark night, look up at the sprawling canopy of the Milky Way. Look at the thousands of burning suns and the tens of billions of invisible worlds orbiting in the freezing black. It is not an empty ocean waiting for us to set sail. It is a minefield. It is a cosmic test. And the absolute deafening silence you hear is the sound of a universe that has been running this exact same experiment for 14 billion years, waiting with terrifying patience to see if humanity will be the ones to finally break the quiet, or if we will just be the next tiny spark to flare, burn brilliantly for an instant, and then fade forever into the dark.